Welcome to this documentary about the deepest holes on Earth. A journey into some of the most extreme, mysterious, and fascinating places on our planet. In this video, we'll explore incredible natural formations carved over millions of years, as well as astonishing human-made boreholes that push the limits of science and engineering.
From massive underwater sinkholes to record-breaking drilling projects and hidden worlds beneath ice and rock, you're about to discover how far curiosity has driven us into the unknown. So sit back and let's dive deep beneath the surface of our world. The story of the deepest holes on Earth brings together some of the most extreme natural formations and extraordinary feats of human engineering ever achieved. These holes range from great underground caverns carved by nature over millions of years to deep scientific and exploratory boreholes drilled by humans in pursuit of knowledge about our planet. Exploring these deep points reveals not only geological wonders, but also the limits of technology, the richness of ecosystems hidden from sunlight, and the relentless curiosity that drives scientists and adventurers to push deeper into the unknown. One of the most remarkable natural features on Earth is a water-filled sinkhole in northeastern Mexico known as El Zacatón. This sinkhole is part of a system of unusual deep vertical shafts formed in limestone rock. El Zacatón is renowned for being among the deepest water-filled pits on the planet. Its total depth from the rim to the deepest point beneath the water surface measures more than 300 meters, and the underwater shaft itself descends over 300 meters below the waterline. The sinkhole's waters are unusually warm because geothermal activity beneath the surface heats them. Because of its extreme depth and conditions, El Zacatón was selected as a testing ground for advanced autonomous robotic explorers, which have mapped its underwater geometry and helped scientists understand how such features form over geological time. The sinkhole was the site of record-breaking deep dives by professional cave divers, though such exploration is hazardous and has claimed lives. Beneath the surface, scientists have also discovered diverse microbial life adapted to live without sunlight, hinting at how life might exist in similar environments on other planets. In stark contrast to natural sinkholes, the deepest hole ever made by humans is the Kola Super Deep Borehole in northwestern Russia. This borehole was created as part of a scientific research program with the goal of penetrating as deeply as possible into Earth's continental crust. Drilling began in the 1970s and continued for nearly 2 decades. The deepest point reached by the main borehole was more than 12,000 meters below the surface. Reaching this depth required overcoming tremendous technical challenges as the rock and drill equipment were exposed to temperatures and pressures far more extreme than anticipated. At the bottom of the borehole, temperatures exceeded 180 degrees Celsius, far hotter than models had predicted, and the rock became so plastic that it behaved much like a viscous material under pressure. Although the project was ultimately halted before it could reach the boundary between the crust and mantle, the Kola Super Deep Borehole remains the deepest true vertical hole ever drilled by humans and represents a major milestone in our ability to explore the deep. The borehole provided scientists with valuable data about the composition and behavior of rocks at great depths, challenging assumptions about the structure of the planet's crust and revealing unexpected features, including ancient microscopic fossils and water reservoirs far below the surface. Beyond the Kola Super Deep Borehole, many other deep drilling projects have sought to extend humanity's reach beneath the surface. In China's vast Tarim Basin, Engineers and geologists have drilled exploratory wells that extend downward more than 10,000 meters. These deep holes are part of efforts to study Earth's deep layers and to explore resources such as oil and natural gas. The technical challenges of drilling so deep in desert conditions are immense, with rising temperatures, pressure, and rock hardness testing both machinery and materials. Another remarkable human-made deep installation is found not underground, but beneath the frozen ice of Antarctica. The Ice Cube Neutrino Observatory, located at the South Pole, is not a hole in the conventional sense, but it represents an extraordinary deep excavation into a natural medium. To install this observatory, scientists used hot water drills to melt deep vertical shafts into the Antarctic ice sheet, reaching depths of nearly 2.5 kilometers. Into these deep ice holes, they lowered thousands of sensitive optical sensors. These sensors are frozen permanently into the ice and detect faint flashes of light created when elusive subatomic particles known as neutrinos interact with the ice. This project allows scientists to study high-energy particles from distant cosmic sources by effectively turning a cubic kilometer of deep ice into a giant particle detector. The Ice Cube Observatory continues to be expanded and upgraded, bringing new insights into astrophysics and the fundamental nature of the universe. Natural deep holes are not limited to water-filled sinkholes. Some of the deepest vertical geological formations are massive sinkholes known as tiangkings. One such feature is the Shaozhai Tiangking in southwestern China. This enormous pit has near-vertical limestone walls that plunge more than 500 meters from top to bottom. The pit formed through the collapse of a large underground cave system combined with long-term erosion processes. During rainy seasons, waterfalls cascade into its depths, and the dramatic drop from the rim to the floor creates a stark view of Earth's dynamic geological processes. The scale of this feature is immense, with its opening spanning hundreds of meters and a volume measured in tens of millions of cubic meters of rock removed over time. Caves represent another form of deep natural holes, and among them, some of the deepest on the planet are found in the limestone massif of the Caucasus Mountains in the western Caucasus region. Veryovkina Cave, located on a remote mountain slope, holds the record for the deepest known cave on land. From its entrance, high on the mountainside, passages and shafts descend more than 2,000 meters into the earth. Exploring these passages requires specialized climbing and rope techniques, as well as technical diving in submerged sections. The challenges of navigating such deep caves are significant, with narrow shafts, cold water, and complex networks of passages that have formed through long-term dissolution of limestone by underground water. Human exploration has also extended into other deep natural formations, such as underwater sinkholes known as blue holes. These features are submerged vertical pits in the seafloor that can reach astonishing depths. One example, discovered more recently, is a marine blue hole in the waters off the Yucatan Peninsula that has been measured at over 400 meters. Blue holes are fascinating to scientists because their isolated environments can preserve ancient sediments and unique ecosystems, and their depths have yet to be fully explored in many cases. While not all deep holes are vertical shafts or drilled boreholes, some of the deepest places on Earth are found in the ocean. The deepest natural depression on the planet is the Challenger Deep, located in the Mariana Trench in the Pacific Ocean. This point lies nearly 11 kilometers below sea level and marks the greatest known depth in Earth's oceans. The pressure at these depths is immense, and yet life has been found thriving in extreme conditions there, including specially adapted fish and microbial organisms that survive without sunlight. Throughout history, humans have also created deep vertical shafts through mining operations. Large open-pit mines, such as some of the deepest mines in South Africa, extend several kilometers below the surface to extract valuable minerals like gold and platinum. These mining operations require extensive networks of tunnels and shafts, with some vertical lifts descending more than 3 kilometers into the earth. These engineered holes are not only feats of extraction, but also represent significant challenges in ventilation, safety, and the management of heat and pressure at depth. The pursuit of deep holes extends beyond geology and resource extraction into scientific exploration with ambitious future goals. Scientists continue to propose projects that would allow drilling even deeper into Earth's crust to reach layers unattainable with current technology. These proposals involve new drilling techniques and advanced cooling systems to withstand intense heat and pressure. However, even with unlimited funding and modern advancements, the limitations imposed by Earth's internal conditions, including extremely high temperatures and rock plasticity, pose significant obstacles to reaching the mantle or core. Whether formed by natural processes over millions of years or created by human ambition and engineering prowess, the deepest holes on Earth reveal the powerful forces at work beneath our feet. They show us not only how much remains hidden in the dark depths, but also how human curiosity and ingenuity drive us to explore ever further. These deep places, from water-filled sinkholes in limestone to scientific boreholes and particle detectors trapped in Antarctic ice, remind us that the story of Earth extends far below the surface, into realms both mysterious and filled with knowledge waiting to be uncovered.
Thank you so much for watching this video. If you enjoyed it, please don't forget to like and subscribe to the channel.